Hello everyone, this is Mr. Jackson, and today we're going to be kicking off our Concept 2 discussion over homeostasis and regulation. So this might be a new term for some. Homeostasis might be new. So what do we mean when we're talking about homeostasis? It's referring to the stability of your internal environment. So maintaining stability within your body and all of the mechanisms that work to maintain that stability. So it's not just the stability, it's all of the interacting mechanisms that help that happen. And so there's a couple different words we can use for homeostasis. We could say stability, we could say balance, we could say it's our body's baseline or our comfort zone. All of this means the same thing, and we want to maintain it if we can. There's another word that we could use, which we employ as human beings, and we like to stay within what we call a dynamic equilibrium. An equilibrium, again, it's just another word for balance or stability, but a dynamic equilibrium means that we can accept a little bit of a range, okay? We can go a little higher than a set point, a little bit lower than a set point, and it not really bother us too much, right? So dynamic can work a little bit high, a little low, it's within a range. That's different from a static equilibrium. A static doesn't move. Static equilibrium would mean that regardless of our external environment, we are staying at a set point and cannot handle anything that isn't that set point. Functionally and thankfully, we use dynamic equilibriums in our body's systems. So that's going to be maintained where the rate of our losses or gains are balanced out, okay? So organisms, as living things, we don't just detect changes in our environment, but we can also respond to them to survive. And homeostasis is going to be maintained through regulation by incorporating our responses from our organ systems all the way down to the responses that might occur at the cellular level. Some common examples are blood pH. We don't have to stay at exactly a set pH. It can get a little more acidic or a little more basic, but we do want to stay within a given range. Same thing for our body temperature or our blood sugar levels. They can go a little higher or lower from what we would consider a baseline, but we want to make sure that they stay within a certain range. And your body's going to maintain this homeostasis through what we call feedback mechanisms. And we have two of those. These evolved to basically help us maintain that stability. Everything's contributing towards keeping us comfortable. And so these loops, these feedback mechanisms, are going to use the output of some organ system, and again, all the way down to the cells that make it up. And that's going to respond to some initial signal or input so that your system responds in whatever way is most appropriate. Now, it can either respond to stabilize based on the input, so meaning we come back down to baseline, right, to that comfort zone, or it can be amplified, meaning that we're going to elevate the initial input and make it happen even more, and that's usually good for accomplishing certain objectives when we need to. So this can be positive or negative, but remember, the three parts of this is that we have an input, the systems that might respond, and then the output of those systems to either enhance or to inhibit the initial input. So these two types of feedback mechanisms. The first one is a positive feedback loop. This is where the output of your system or systems is going to intensify the initial response. Your body responds to an input by actually making that initial input occur more, right, to a greater extent. It amplifies the initial extent of that input. Some common examples in anatomy would be your body's ability to clot whenever we're gonna try to heal a cut or a scrape. We'll have an example in class where we actually work with an example of that using sticky notes, and you guys will be against the clock in order to put this into practice. Another example, human childbirth, as you see here, where the release of hormones, that input, causes contractions and pressure, which then stimulates systems to give the output of more hormones, which cause amplified contractions, amplified pressure, and so on, up until the point where we deliver the child. Fruit works the same way. Whenever a fruit starts to ripen, it will release what we call ethylene, and that will actually signal all of the surrounding fruit that, hey, it's time to ripen. And so that causes more and more fruit. So it's kind of like a ripple effect, right? Where the initial input is going to be amplified or enhanced. And finally, the other side of that coin is we could also have negative feedback loops. And this is actually the majority of what your body is doing, all of its organ systems are doing all the time, okay? Most of the time, I'd say 99.9% of the time, we are functioning and surviving off of these negative feedback loops. So this is where the output or the response of a system is going to stabilize or basically counter the initial input. So some kind of a homeostasis is challenged, and your body's mechanisms work together so that we can bring it back down to baseline, back down to stable. So some examples would be human body temperature, right? So if I were to go out into into my environment on a hot day, and that would basically raise my body temperature, I've got mechanisms in place like my blood vessels could dilate and I could sweat to cool my body so that I could bring it back down to baseline. This is also how we maintain water concentrations or hydration levels in our bodies, blood sugar staying within a dynamic equilibrium. All of these things, again, there's no shortage of examples, and we're going to be covering this all year as we cover each of our organ systems and how we respond to challenges in our environment. And so I think that's going to be plenty for part 2A. So we'll see you at the next one.